Okay, so the first method we're going to discuss in terms of determining whether a polynomial is a factor of a larger polynomial is for us to do long division. So the steps are the same that you do for regular long division with numbers, and that's what we're going to fill in here. So the D stands for divide. So remember our example that we did on the previous video. What am I dividing? Well, I'm dividing 12 divided by 3, and I decide that that is a 4. So the next step is to multiply that factor and multiply it with the divisor. 4 times 3 is 12. Then my next step is to subtract. So I'm going to subtract those two, and I get 0. And then if there are any other numbers, then you need to bring those numbers down one at a time. So in this case, there's just a 6. And then the process starts all over again as we did in the previous example. Okay? So the process is going to be the same when we're dealing with polynomials and we're dividing, such as the ones down here, number 1 and number 2. Okay? So there are a couple of things, There are a couple of things that we need to mention about this process before we get started. And that is that when we are doing these, we are going to, in order for us to do this, it's a lot easier when we're dealing with numbers because there's usually, and sometimes there's more than one, but usually there's a single digit. Sometimes there's a double digit, and that's a little more difficult. Well, down here we have a binomial, and it's being separated with an x plus 2. So it's going to look kind of strange because it's going to look something like this. And that looks a little strange. So it's a little confusing, like how are we supposed to determine what to divide here? So just like you did up here, when we are doing whole numbers, we kind of look for the smallest number that 3 can go into. So down here, we're looking for the smallest number of terms that a binomial can go into. Well, a binomial is 2 terms. So that means that we are going to use this portion right here, this front portion, to make that divide into this. But again, you're probably looking at it going, I have no idea, like how am I supposed to figure out how many times this can go into this, okay? So what we're going to do is we're going to use a little shortcut. We're going to look at just the first terms, okay? And we're going to divide the first terms of each polynomial to get us started. That's what we're going to look at. So for example, down here then, I'm going to look at this x term and this negative 2x cubed term. And I'm not going to pay attention to the 2 or the 5x squared just yet. So I'm going to basically see how many times or what do I have to multiply with x in order to make negative 2x cubed. So obviously you need a negative 2. You can see that. So I'll just go ahead and put a negative 2 up there. Use a different color here. So negative 2. And if I have an x and I need to get to x cubed, I'm going to also need x squared because x times x squared is x cubed, okay? So that's what I need, okay? And actually, I'm going to write it over here above the binomial that I'm working with because that's where, like just like over here, I write it above the 2 that's in 12. Down here, I'm going to write it over here above the 5x squared because look, it's an x squared term, okay? So once I write it up there, I use the first terms to help me do the division, but when I get ready to actually do the multiplying step, I'm going to multiply with both of the terms, okay? So I'm now going to multiply negative 2x squared, but I'm going to multiply it with both the x and the 2. So I'm going to do negative 2x squared times x. That would give me negative 2x cubed. And then I'm going to do negative 2x times 2, so that would be negative 4x squared. So I've done the multiplication step, okay? So now I need to be very careful because when I get to the subtraction step, there's already a subtraction sign. But remember, that's not a subtraction sign, that is a negative sign. So when I write in my subtraction sign, what you need to be very cautious of is that this negative is going to basically make the signs become the opposite, which is what you want because think about it. If you do negative 2 minus negative 2, I'll just write it off to the other side. Well, that's the same thing as negative 2 plus 2. You want that to become a 0. You want these terms to cancel out, okay? So you're going to have to be very cautious that when you get to the step of subtraction, you're going to have to understand that you need to remember to distribute. That's what you're going to write up here. To distribute the subtraction sign, or I'll say the negative sign because it means the same thing. So this negative sign out here needs to attach, or you're basically subtracting both terms. So this is negative 2x cubed minus negative 2x cubed, which would be the same thing as negative 2 plus 2, and 5x squared minus negative 4x squared. So essentially what's going to happen is both of these signs are going to change to a plus. Negative 2 minus negative 2 becomes negative 2 plus 2, which is 0, so we don't need to write anything down here, okay? And then likewise, 5x squared minus, whoops, let me write it out this way. Let's just do the coefficients. 5 minus negative 4 is the same thing as 5 plus 4. So when you do the subtraction this time, you're actually going to get 9x squared. At first glance, you're going to go, no, that's not right. It's 5 minus 4. No, it's 5 minus negative 4. So you got to be very cautious. If you have to, come out here to the side and write the integers. If you still feel like there's times when you don't have a good firm on your integer rules, it'd be a good idea to come out here and write this. Okay, so now I'm going to go ahead and I'm going to bring down. So the next thing that I have to bring down is a negative x. So I'm going to bring that down. Oops. Negative x. And then the process starts all over. So I'm going to divide again, but this time I'm going to be dividing this into this. So clearly you can see that you're going to need a 9, okay? And you're going to need another x. So I'm going to write up in my answer, and it'll be a positive. If this is not a negative coefficient, you're not going to write a negative up here. The first one was negative, so that's why there's a negative. But this one is a positive 9x squared, so I'm just going to need a positive 9x up there. And then again, I'm going to multiply. 9x times x, that's going to give me 9x squared. 9x times 2 gives me 18x. And then again, I'm going to put my subtraction sign in, but be very careful that when you put it in, you put these in parentheses. Okay? So this is 9x squared minus 9x squared. Well, 9 minus 9 is 0. But this means negative 1x, and negative 1 minus 18 really means negative 1 plus negative 18. That's negative 19x. So now I've got a negative coefficient again, okay? So the last number to bring down is the 2. Oops. Bring that down, it's going to be plus 2. And I got to do the process all over again. So this time I'm going to be dividing x into negative 19x. So since it's negative 19x, I'm going to need a negative 19, obviously, up there. And then I already have an x, so I don't need another x. So negative 19 times x is negative 19x. Negative 19 times 2 is negative 38. Now again, be very careful. When we are subtracting negatives, these are both going to change signs. This is going to be negative 19 minus negative 19. Negative 19 minus negative 19 is really negative 19 plus 19. Okay, that's going to cancel. 2 minus negative 38 is really going to be 2 plus 38. 2 plus 38 is 40. So I'm going to end up with 40. Oops. I'm going to end up with 40 as my remainder. And so I'm going to come up here and I'm going to write at the top R40. Okay? And this right here is my answer. So if I were to try to factor this using x plus 2 as a factor, you would have this remaining. Okay? You'd have this with a remainder of 40. So here's the important factor, okay? I'm going to skip step number 3 for a minute because that's only going to apply to number 2. If there is no remainder, then the polynomial is a factor. Just like up here, when I did the division, I had a 0 remainder. We would say that 3 is a factor, okay? So if there's no remainder, then we say that the divisor is a factor, okay? Well, in this case, there is a remainder. So therefore, that means that x plus 2 is not a factor. It's not a factor of this polynomial. So basically, we just checked it, and it's not a factor. Now, we're kind of building up to factoring with these, okay? So we're going to be factoring with these, but I'm showing you the method because these methods can be used to factor some of these, okay? In the next video, I'll do example number 2 so I don't make too long of a video here.